Yeah. Yeah, gentlemen, in our previous class, we discussed about hybrid and non-hybrid installation, and we mainly concentrate on hybrid. And this is exactly what we did. Please, some of you write on our page, please throw more light on it. This will throw more light on it. As I said, if you are not be following us, please do that to follow us. Our mission is one youth, it is key. So please, what we did here, we talk about 48 volts system as I was talking about from our previous class. Depends of the inverter information, the manufacturer information determine how you are going to do your installation. Determine the numbers of panel that you are going to use. Also determines the size of battery, either 48 volts or 24 volts. But in our previous class, we talk about 48 volts. And this is the 48 volts, 12, 12, 12, 12 into 4. We connect the series to make 48 volts. As I said, the series, positive, negative, positive, negative, positive, negative. Then, and from the installation, from our hybrid installation, we have already labeled it. This is the screen. These are setting and control button, and this is the PV where the solar panel is coming, and this is the battery. This is the input voltage, and this is the output voltage. That is good. Now, this is the output voltage supplying the building. Okay, good. Now, as a beginner, maybe an installer came to do this thing for you. This is an O level. It is called what? What will I call this kind of installation? Somebody came to do this installation for you. How will you call? Please let me just ask the audience. This word substandard word installation. Because why? Why is it substandard? Because there is no protection system. Now we'll be looking into protection system in this inverter. Please, I don't want to take much of your time. I'm going to concentrate on only the input protection so that the video will not be too long, so that it will not be bore for you to watch. So now, as I said, we have what? Input what? We have the input. So now we are looking at what? The breaker. When choosing breaker, you have to, you don't just choose breaker because you want to protect your inverter. You choose breaker based on the manufacturer specification. If it's 10 kVA, for instance, the breaker that you see there for the input breaker is 63 amp. Please use the 63 amp for the required breaker. Oh, someone called me my page. I use the required breaker that the manufacturer specify. Note, there are good breaker in the market and there are also substandard breaker in the market. If you use substandard breaker in the market, you will also run into trouble. It's going to burn. Okay, let me say this is 63 amp. For me, sometimes I like using one pole, but in this case, I'm going to show you two pole 63 amp breaker. Okay, this is 63 amp breaker, and we have the positive. Your breaker is always like this. Okay, up and down. Okay, we have what? Live and what? The neutral. Okay, live and what? The neutral. Note, when we are talking about the input breaker, always know that what we are talking about the AC. The AC what? Breaker. You know, in the inverter, we are talking about the DC breaker and the AC breaker. But we are talking about the input protection because now we are starting from here: input, output, battery, and the PV. But what we are concentrating on what? This input what? Protection. So I don't want to make it bulk. This is the, okay, this is breaker. What does breaker does for the input? The input breaker is for you to protect what? Short circuit, and for you to protect what? Over what? Load. That is what breaker does. But outside this, there's what we call AVS. And AVS is very, very important. The AVS, we have what? AVS. AVS. And the AVS also have what? Live and what? Neutral, live neutral. Okay. This AVS, what does the AVS does? It's called what? Voltage what? Regulator. It regulates your voltage for under voltage and for what? Over voltage. Because there are some building, there are some environment whereby their grid maximum voltage is 170, or while some their grid highest voltage, is the voltage that flow through their system about 280, 290, but they will not tell you. At times it will just go to 300 on in a single phase, installation. Either it burn it or over voltage, or either it destroy it. So now this where AVS have to play a role. So and we are talking about the surge. What is missing in this place here now? We are talking about the surge. The surge what? Protection. We call it what? SPD. Abi? S what? SPD. That is a surge protective what? Devices. It's like this. It look like this. This is what? Live and what? Neutral. The other displays, this is what? The 80 system. Is it clear? SPD. Please note this SPD. So now, what are we going to do? We are trying to bring out our breakouts. What we are going to do, these are one of the protection. And okay, let me also draw our changeover. This is what? Changeover. You know, in our changeover we have live and neutral. This place is the what? For load. These are the loads. And you have what? Live and neutral. This can be for inverter. And this is for what? Grid. Zero ID. For grid G, that is for grid. Okay. So this inverter, this is load. This one is load. LOAD. Live and what? Neutral. The way it is. I'm only just as I say I'm only concentrating on what? On the input protection. I don't want it to be bulk. Now you can see, as I say, if someone do this installation for you, please, this is for O level. And secondly, okay, let me not divert. Let me not divert. Okay, this is clear. I'm going to connect it into a box now. So you can see this is our grid. I'm going to cut it off. You can see, sorry, I'm going to cut it off. They have where's my board? Okay, I'm going to cut it off. And this is my supply, my Apple supply. I'm coming there. I'm going to also cut all these ones off, maybe to protect it. Now I'm coming gradually. Now I'm concentrating on the input first for us to understand. Oh, I want to protect my system. For me, first and foremost, you will first take it straight to the AVS. This is your neutral. As I said, this is my grid. Do you see? And this is my life. Okay, this is my life. So it's passing through the AVS. Why is passing through the AVS? It's for you to monitor the voltage. I don't want low voltage to pass, because there are some system. The manufacturer said don't allow voltage below 190 to pass through it, and don't allow voltage above 230 or 240 to pass that particular system. If you do, you will end up destroying this system. So what are you going to do? You set that required voltage on the inverter. Place under voltage 190. You set it here, and over voltage 230, depends of your region, the required voltage required for the manufacturer. Then this is AVLs. Then on top here we need to protect our input. Okay, now you can see this is input and there's a hole here. So now in life to life, can you see? Then neutral to neutral. Is it clear? Then in this place, it's very simple. It now is also very simple. We have the SPD. It's very simple for you to equally do neutral to neutral, the live to live. Is it clear? Now we have there's one space left here. Am I right? Live and what? Neutral. So where is it going? You can see this is our input. Do you see our input? I circle it. As I said, our earth is earth number 18. So we have live and what? Neutral. So this is our neutral. So our neutral is coming to the neutral. Then our live is coming to live. So from this video, we have actually protect our input what? Voltage. Mark this X and this X, they are going to leak. When I say X and X, they are going to what? Leak. I'm trying to make this video short. They are going to leak. Is this explanation clear? If it's clear, please say it's okay. Is it clear?
It's clear, sir.
Okay. Now we are going to change over. Is there any thing that you want me to explain about this changeover? I said for the changeover, this is what inverter down. I'm going to use my down as what inverter output. This where this output now. I'm going to put it. I'm going to connect this output. Now, if you on your inverter, as everything here is working, if you on this inverter, if you switch it on, it's going to produce output. So this output, we have what? Live. Please don't mind the way it is. I said this is my live. Is it clear? And this is my inverter output. Neutral. You can see. Now there's output here when you on it. Okay. The loads. This is load. The load that is why I actually record. I close this place. This is my neutral and this is my neutral. Note, I want to power this house. This neutral is coming to this place. Is the load of the house, and this light is coming to this place. Now, if you bring down your changeover down, you will see that it will supply this house. There will be light. There will be supply in this house. Then now we are talking about the grid. Why are you now introducing grid? We are using this as a backup system. Okay, let's assume your inverter has problem. Someone is asking me when I say grid before making this video. He's asking, yeah, who has that question? What we say grid? Is it NEPA or generator? Where in Nigeria we might call it NEPA. So please accept our grid when I say NEPA. Okay, now this is grid. So in this grid now we are talking about how is the grid going to come? Before you come to do this installation, there's already existing changeover, as the case may be. So now this is changeover, the existing changeover. Okay. In this existing changeover, so I'm coming to this place. I'm coming to this place. In this existing changeover, note, if you're in Nigeria, you understand what I'm talking. If you're in another country, your grid has a name. Okay, we call it PHCN. I'm in Port Harcourt. Precisely, I also operate from Lagos. So Now this is a NEPA, and this is what generator. This is generator. And before you come to do this installation, at this center here is changeover. This is changeover, as I said. Eh? Changeover. Before you come to do this installation, there's existing load here. Am I right? Please, if it's clear, let somebody say it's clear.
Yes.
Okay. There's this changeover. There's load here before. Load. So in this place, what you are going to do, this is the load you are using now. You are removing this load. It is this load that was powering your house before. So it is the one that you are taking to this place. Okay, this is the load you are taking to this place. You are not removing. So this place become what? Empty. Am I right? Or except the load that you don't want to be on the inverter, it is the one that will be on this changeover. Because maybe when we'll talk about load separation. When we are talking about load separation, it's another ball game. I don't want to make it bulk for your comprehension. That is why I'm just making only the input, because it will be bulk for you. Okay, now you remove this one. This is now the load that is coming to this place. Then this place become what? Empty. So now this place that is becoming empty, what you are going to do is for you to use another wire. You take it to, this is okay, let me take this live and what? Neutral. You take the live straight to this grid, that is to this place. Then you take the neutral to this place. Now this is what? Inverter what? Output and the grid, and this is our load. That this is the load that you remove from this changeover and take to this place. Now in case of emergency, the reason why you are introducing this, you are introducing this very changeover is for backup. Let's, for instance, you want to, there's an emergency, maybe the person who do the installation for you is far off, he cannot come instantly, or maybe at the middle of the night. Proster, please, there is no light. I don't, okay, please, is there NEPA, or please just turn on your generator and take your breaker to grids as a backup. It's just as a backup. So that is usually why we are creating this particular place. So guys, I believe it is clear. If it's not clear, please, I need a question from the audience, please.
Sir,
Yeah.
this surge protective device, how does it come into play? What does it do?
Okay. The surge is for lightning protection. It's for lightning protection, so that it will not destroy your system. These are among the features that you add to your cost in order for you to protect your installation against lightning.
Does it also come rated like the breakers?
Yes, it come rated. We have it in different KE, so that is going to be another topic. Okay. If you go to our previous installation on YouTube, you will see some of our explanation on SPD.
Thank you, sir.
So is there any other question, please?
Okay, sir.
Yes.
My question is on that AVS.
Okay.
So I want to know more about that AVS. That AVS, is it going to protect anything that is going to happen in the house? That is the whole building.
So the AVS is a protective devices against voltage fluctuation. What I mean by voltage fluctuation is that the manufacturer said this your inverter is the input voltage, the minimum voltage required to protect your system, that is to flow into your system, is 190 volts or 200 volts. and the maximum voltage required to flow into your system, the maximum is 230 or 240. Now, in your environment, what your NEPA is supplying you is 170. When you go for as an installer, you went for that particular place, you use your multimeter to test the voltage, and your voltage that you discover in that environment is 160. Oh, because you want to win the contract, you allowed yourself to use that is to put in without using this AVS. Oh, some people will tell you, some customer will start shouting, I don't need AVS. Anytime there is low voltage, my inverter is not charging. Please, young man, as an installer, don't listen. Ask them to sign or that take it, or they buy stabilizer, a stabilizer that can regulate the voltage from 160 to 200, that will accommodate your input voltage. That is the essence of this AVS. So this AVS help you to guide your system so that unwanted voltage will not just flow into your system and destroy your inverter. Is it clear?
Yes, that's clear, sir.
So when you get to the output, I'm also going to show you something about AVS. I'm going to teach you something about AVS on output voltage. I'm going to show you something how all these things that we are demonstrating here. As we are demonstrating it, guys, we are going to practicalize everything. This is just the theoretical part. I'm going to bring everything live, then you are going to see it there. We are going to be showing you introducing unwanted voltage and show you how it's going to work, going to bridge a breaker to see how it's going to work. So if there's any other question that you feel that is not understand to the audience, please also ask question so before we post it. Any question from the audience? No question. So I believe every one of us have digested this video. So guys, on our next video, we are going to progress with what we have explained here. We are going to start from this input. Our next topic, we're also going to talk about the protection, about the output, about this output voltage, about the PV, and about the battery. So guys, thank you for your patience, and all our followers, thank you for following us, and may bless, God bless you. Remember, our mission is one youth, it is key. God bless.